I'm glad you came back for some more stoichiometry. This is part 3. Okay, objectives. You will be able to calculate the percent by mass of an element in a compound. You will interpret empirical formula. You will compare and contrast empirical and molecular formula. Calculating percent composition of an element. The same percent formula for everything you have learned since middle school. Percent by mass of an element is the mass of that element in the compound over the mass of the whole compound. This is percent, so you have to time it by 100. Percent composition equal part over whole time 100. Percent equal part over whole time 100. Let's practice. Calculate the percent composition of the elements in ammonium sulfide. When they don't specify any element in this compound, that means you need to do it for each element. When they don't give you a mass, you need to assume it is 1 mole. Okay, if they give you a mass, you do the percent composition based on that mass. If they don't give you any mass, you do it based on molar mass. Okay, 1 mole. This is what we do. The first thing you need to do, you have to make sure you know the formula for that compound. And here we go again. This is chemistry. You build on what you have learned before. So if you don't write the right formula for the compound, all your answers will be wrong. So, what is the formula for ammonium sulfide? Ammonium is NH4, sulfite, sulfate, SO4 2 minus, sulfite has to be SO3 2 minus, ammonium is 1 plus, and it's 2 ammonium for every 1 sulfite. So, here's the formula. Now, I need to list the elements in that compound. So I have nitrogen, I have hydrogen, I have sulfur, and I have oxygen. Alright, I will show you in class how to use your graphing calculator to do this faster. Alright, so I may not be able to do it with the video. In class, make sure you have your graphing calculator, we will do it. So what I will do, I will write down the mass of nitrogen from the periodic table, which is that 14? 14 point what? 01. This is the mass of nitrogen from the periodic table. I count how many nitrogen I have in this compound. I have 2 nitrogen. Give me a mass of 28.02 grams nitrogen. I do the same thing for each element. This is hydrogen. Hydrogen is 1.01 grams. Correct me if I'm not right. And they are 4 times 2 give me 8 hydrogen for a mass of 8.08 grams hydrogen. Okay, sulfur. I have sulfur. I think it's 32 point something. 32.7 07 grams times I count how many sulfur is only 1 equal 32.07 grams of sulfur. This is my oxygen. Oxygen is 16 grams oxygen times I count how many oxygen, only have 3 give me 48 grams of oxygen. Now, this is the mass of each element in the compound. I need for you to please quickly add all of those for me. All of this. This will be the molar mass of ammonium sulfite. The molar mass of ammonium sulfite is, say that again, 116.17 grams. This is my whole. Now, I need to divide. I need to take each one and divide it by that whole. What is 28.01 divided by 116.7? That's what I said. This is tedious. So if we can find a way to do it on the calculator, we won't have to keep on dividing by the same thing. So we will do it in class. So what is 28.02 divided by 116.17 times 100? 24.12%. Make sure you write percent. Percent of what? Percent nitrogen. Okay, so what is 8.08 times divided by 116.17 times 100? 6.96. 6.96% hydrogen. What is 32.07 divided by 116.17? 27.61% sulfur. What is 48 divided by 116.17? 41.32% oxygen. If you want to see if you are right, when you add all of those percentages, they should give you 100. So this is the percent by mass of each element in that compound. Okay, this is what I will be doing in class, showing you in class how to use. But because of time, I'm not going to do it now. Okay, let's quickly solve this one as a practice before we move on to something else. When a 13, now they give you a specific mass, when a 13.60 gram sample of a compound containing only magnesium and oxygen, only those two elements, the mass of oxygen is, okay, 5.40 grams oxygen. What is the percent composition? When they ask percent composition, you need to do it for each element in the compound, for each one. So what we will do, if I have the whole, this is my whole. There are at least 2 or 3 different ways you can solve this. Easy way, this is the mass of my oxygen, 5.40 grams oxygen divided by the whole, which is 13.60 times 100 equal, what is it? 5.40 divided by 13.60 times 100. 39.7. 39.7% oxygen. Okay, because I'm lazy, the easiest way to do the other one, I would just do 100 minus that percentage, give me the percent of the other one. Okay, so this is the shortest way. Or you could take the whole mass minus the other one, give you the mass of the magnesium, take the mass of the magnesium, divide by the whole times 100. So what is 100%, which is the whole, minus 39.7% equal what? 60.3% magnesium in that sample, because there are only 2 elements. Okay, propane, the fuel commonly used in gas grills, is one of the compounds obtained from petroleum. Calculate the percent composition of propane. I don't think I'm going to do this to save time. Alright, because it is the exact same thing. You use propane, this is 3, this is your carbon, This is hydrogen. Okay, you put the mass of carbon, which is 12, times the number of carbon, which is 3. I said I wouldn't do it, and I end up doing it. Hydrogen 1.01 times 8. This is 36. This is 8.08. I take the whole, which is that 44.08 whole? Tell me if I'm wrong. Okay, this is my whole. So I do 36 divided by 44 times 100, and I do 8 divided by 44 times 100. Will give me the percent of each one of them. Okay, let's move on. Now, we are done with percentage. Let's go with empirical formula. What is empirical formula? Empirical formula. It is the simplest formula. What happened to my action? It is the simplest formula of a compound where the ratio of the atoms are expressed in the lowest whole number ratio possible. The empirical formula for water is H2O. Okay, the ratio is 2 to 1. You cannot reduce it anymore. So the molecular formula in this case is the same as the empirical formula. But the empirical formula of glucose is not C6H12O6. Alright, because those are not the simplest ratio. The simplest ratio is CH2O. CH2O. Okay, the empirical formula for ethane is CH. The empirical formula for styrene is CH. The empirical formula for benzene is CH. The empirical formula for ethanoic acid is CH2O3. Just reduce it to the lowest term. Empirical formula, simplest form. Now I have a challenge for you. You need to have your calculator because I have been too easy on you. Let's do something a little bit more challenging. A compound is analyzed and found to contain 25.9% nitrogen and 71.1% oxygen. That's what they gave me. They gave me the percent composition of each element. They asked me for the empirical formula. They give me percent composition. They asked me for empirical formula. I need for you to listen carefully. That's why students have problem with this type of problem. But, you know, there is always, I always find a way for you to make those very hard things a little bit easier. I have a rhyme for you. So if you learn your rhyme, you will know exactly what to do step by step. And doing tests, believe me, I'm telling you the truth, I see students reciting the rhyme before they solve a problem like that. The rhyme goes like that. This is a simple rhyme for a simple formula. You get it? Empirical formula. Percent to mass, mass to mole, divide by small, multiply until whole. That's all you need to know. Okay? Strategy for converting percent composition to an empirical formula. A simple rhyme for a simple formula. Percent to mass, mass to mole, divide by small, multiply until whole. Let's go back and recite a rhyme to solve this problem. The first line of the rhyme says percent to mass. Always assume 100 grams of your sample. Okay? That's mean that percentage is the mass. So I will write 25.9 grams of nitrogen in that compound. And then I will write 74.1 grams of oxygen in that sample. Percent to mass, mass to mole. I am going to convert each one of those mass into moles. So get your calculator ready for me and periodic table. So this is grams. This is, I want moles. This is 1 mole has, 1 mole of nitrogen has 14 grams of nitrogen. And if I to check for me, I'm just putting the mass from my head. I don't have to be right. Okay? So I do the exact same thing with each element in that compound. So I do convert it to moles. This is moles. This is grams. Grams of what? This is grams of oxygen. This is grams of nitrogen. So 1 mole of oxygen has a mass of 16 grams oxygen. I cancel grams. Cancel grams. What is 25 divided by 25.9 divided by 14? Say that again. 1.85. 1.85. This is moles of nitrogen. What is 74.1 divided by 16? Repeat. 4.63. This is moles of oxygen. Percent to mass, mass to mole, divide by small. The smallest one of those moles is 1.85. Divide by 1.85. So what is one? This is 1 nitrogen, and this is what is 463 divided by 185? 2.5. 2.5. This is for my oxygen. Percent to mass, mass to mole, divide by small, multiply until whole. I don't want that decimal to be my subscript from that formula. Multiply until whole. If it ends with 2.5, I multiply by 2. If it's end with 0.3 something, I would multiply by 3. If it's end by 0 point something, I round it up. I call it whole. If it's end with 9.9 something, very close, 9, I would call it whole. Alright? So I multiply those two numbers by 2. Multiply by 2. This would give me 2. This will give me 5. The empirical formula is N2O5. This is the empirical formula. Alright? So remember the rhyme. Percent to mass, mass to mole, divide by small, multiply until whole. I said 48. This is the last one, I promise. Let's do the last one. Let me just, yes, let's do the last one. Calculate the molecular formula, not empirical. They asked me for molecular formula of a compound whose molar mass is 60.0 grams per mole, and the empirical formula is CH4N. They asked me for the molecular formula. They give me the empirical formula. This is what I do. The empirical formula, which is C4, well, it is C, not C4. It is CH4N. That empirical formula, mass times a number, will give me the molar mass. Let me repeat. The empirical formula, mass times a number, will give me the molar mass, because the empirical formula is the simplest form from that molecular formula. So the empirical formula, mass is carbon is 12, hydrogen is 1 times 4, give me 4, nitrogen is 14, equal 12 plus 4, 12 plus 4 give me 16, 16 give me 30. This is my empirical formula, mass time a number will give me the molar mass. They gave me the molar mass, which is 60.0 grams per mole. I solve for that. X equal 60 divided by 30 equal 2. So my the molecular formula, that X is a 2, the molecular formula is C2H8N2. Okay, empirical formula mass time a number will give you the molecular formula, the molar mass. Find that number and then go back and multiply each subscript in that empirical formula by that number. It will give you the molecular formula. Okay, so thank you very much for your kind attention. I hope you enjoy the rest of your day. Do your homework. Do your homework.